Hi class, it's Mrs. Schnee for the next video, lesson 4, dot plots. And I just wanted to mention today I have at the end of the video a part where you can do a cool down, which is just a practice of the concepts that I'm covering in the video. So there'll be 2 documents that you can print out if you choose to go along with this. And if you don't do the lesson part of it to print out, at least this one somehow, being able to show your work on that would be a great way to practice this. Okay, there's no Khan Academy lesson that's tied with this that I'm assigning. So that would be your extra practice there. Okay, so today's video I brought out a Lego pizza. I was trying to find a prop for each video so that you guys can tell whether you've seen it or not. I know that looking at the pictures on YouTube, it's kind of hard to tell if you've seen it or not. Okay, so we are at dot plots and pizza toppings. The first question talks about 15 customers in a pizza shop, and they were all asked, how many toppings did you add to your cheese pizza? And here are their responses. They have 15 responses here. Could you use a dot plot to represent the data and explain your reasoning? Well, each of these is a numerical piece of data. And when we think about numerical data, we can show those on a dot plot if we choose to. And we'll get a chance to practice that on the next page. One reason why we can do that is, again, because it's numerical, and then also because we have information for each one, and there's some variability here, so we can check it out. Now, before we do the dot plot, we're going to be able to complete the table. It helps us know which dots or how many dots to put on each. So let's go ahead. 0, we have 1, 2, 3, 4. For people who said 1 topping, 1, 2, 3, 4, 5. 2 toppings, 1, 2, 3, and did I miss one? 4. And 3 toppings, we have 1, 2. 2 people want 3 toppings. So I'm going to set this to the side here because the next part of our assignment is to make a dot plot with this information. So we'll go ahead and use the information we know about 0 toppings. So 4 people said they wanted 0 toppings. So 4 dots. 5 people wanted 1 topping. And 4 people wanted 2 toppings. And 2 people wanted 3 toppings. Okay, so now we have our dot plot. I'm going to push this off to the side since we don't need it anymore. All right, so it says use your dot plot to study the distribution for the number of toppings. And distribution is a big word for today, talking about like how is the data spread out. Even though there's infinite number of toppings that you could put on pizza, the people that you asked or the people in the survey said that they only wanted this many toppings. Somewhere between 0 and 3 was the spread here. So let's go ahead and write some sentences that go along with this data. One thing I'm noticing is that most people were going to order 0 to 2 toppings. From 0 to 2, that's where most of the information was. Okay, and then another situation that we could notice is that not anyone that we surveyed wanted more than 3 toppings. So you'll see that we could have other things that we could notice. You might, have a chance to talk to someone about the information and the distribution, but those are the top 2 things that I noticed. Okay. Next it says, think of a statistical question that can be answered with the data about the number of toppings ordered, as displayed on the dot plot. So I was thinking about this, and I know that it's been a long time since we've worked with percentages, so I thought that would be a good thing to talk about. What about if I asked what percent or percentage of people ordered one topping? Okay, so if I wanted to know the percentage, I could look back at the one topping. I could count them up, 1, 2, 3, 4, 5. So that would be 5, and I asked 15 people. So 5 out of 15 if I were working through that as a ratio. And then I could say, how could I get that to a point where I knew the percentage? Well, I know that 5 and 15, there's divisible. They have a common factor of 5, so I can divide both of these by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. So the fraction is 1/3, and that is roughly 33% of the people that we surveyed ordered one topping. So that kind of helps us to know that we can ask statistical questions and we can tie them in with the percentages. All right, let's move on. Homework time, so bye-bye pizza. This one says 25 6th grade students answered the question, how many hours do you generally spend on homework each week? This dot plot shows the number of hours per week that these 25 students reported spending on homework. So you can see one person over here said, nope, don't spend any time on homework. And on the other side, we've got one person that said they spend 9 hours on homework per week. So we've got some differences in there, but our distribution is all the way from 0 to 9. So it's the question that we're looking at says, what percentage of the students reported spending 1 hour on homework each week? So just like that pizza question that we made up, we're now going to think about the percentage there. Well, we know that it was 25 students, so let's go ahead and make that our denominator. And we can count up how many did 1 hour. 1, 2, 3, 4, 5. So 5 out of 25. And if you can remember percentages, percent has to be out of 100. So if I wanted to get my 25 to be equal or equivalent to 100, I could multiply that by 4. And whatever I'm doing to the denominator, I also need to do to the numerator. So 5 times 4 is 20, and 20 out of 100 equals 20%. So 20% spent 1 hour of homework each week. Let's try number 2. Actually, you can pause the video and you can try number 2 and 3 together on your own, and then we'll check back in a second, okay? So go ahead and pause and try those. All right, let's go ahead, and it says, what percentage of the students reported spending 4 or fewer hours on homework? Well, 4 or fewer is all of these students. So we're going to count those up. I have 17 students, so hopefully that's what you counted. And that's out of 25 still, because all of the students were 25 that we surveyed. Again, we want percent, so that's going to be out of 100. So we're going to multiply 25 times 4, 17 times 4, and I'm finding that that's 68. So 68% spent 4 or fewer hours on homework. So that 4 or fewer, that includes the 4 hours. Next it says, would 6 hours per week be a good description of the number of hours this group of students spends on homework per week? This is something that I would definitely need to think about. It says that 6 would be these students right here that spend 6 hours per week on homework. So if I said 6 hours is the typical amount of time, that doesn't really capture these people, and it definitely doesn't capture all of these people. So I would say that 6 is not really a good description of this typical person. I would say that that does not include the people that are outliers, basically. Not outliers, but you know, the people that are more than 6 hours and the people that are behind 6 hours that spend less than that time. So I would say it doesn't really represent that. There's about 19 people out of 25 that are not represented. So let's try number 4. It says, what value do you think would be a good description of the homework time of the students in this group? When I'm trying to think through that, I want to look at where is like the middle information. Where's the middle of this spread of data? Okay, we know 25 people were studied. So if I kind of look and eyeball it right here, I'm thinking somewhere in between like 3 and 4 would be the middle, because half of 25 is about 13. So we're right in there. I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So somewhere in between that. So I would say that typically somewhere in between 3 and 4 hours of homework per week would be the spread, or the more typical amount. Now, this is the part about statistics that people get a little bit, confused on. I want to tell you that, because when you're looking at the numbers, you have your data, but now it's that interpreting it. It's that answering questions about it. And that's the part that is going to take that extra step of thinking it through and understanding it. And that's why this is a lesson that's, it's difficult for people, I will tell you that, because it's something that you have to be able to explain your reasoning, and some people might disagree with you, and you're going to, have to back up your answers and explain why you think that. So let's try another one. It says, someone said, in general, these students spend roughly the same number of hours doing homework. Do you agree? So when you're thinking about all these students, someone said that they spend roughly the same number of hours doing homework. Well, I would disagree with that, because this person doesn't spend any time doing homework. This one spends 9 hours a week. That's quite a big difference when you're thinking about the time that you're spending on doing homework. And really, there's just a lot of variability in there. So I wouldn't say that they're all doing the same number of hours. Okay, there's some spread. All right, so we're to the summary part. Now again, like I mentioned before, this is a tricky part of statistics. Some parts of this is going to be, just calculating things, like finding the average. But when you're really looking at the information and you're trying to answer questions about it, that's where things get a little bit hazy, okay? So the things I want you to understand for this lesson is that when we're trying to talk about typical, like when we're looking at a set of information and we want to know about typical, we're trying to figure out what's the most common or what's expected in a group, okay? And sometimes that's easy. Like with this model here, we've got lots and lots of shapes, and we could say that the typical shape is a circle, okay? Because that's what most of them are. But when you look here, and the question that they're asking is a statistical question about what is the typical length of the squares, the side length of the squares, that's not so easy to tell from this model, because you'd have to actually measure each one. And for that, it would be easier, instead of looking at the model, to take it and look at it on a dot plot. Okay, so taking that information, that data, and putting it here. And because we can then find the spread, we could see that between 2 and 4, kind of like right in this range, that's where most of the data is. So you would say that, somewhere typically it would be around this range instead of from 2 to 7. Okay, so again, this is just you getting used to hearing the word typical, and you seeing that if you had data, putting it on a dot plot, or in our next lesson, a histogram, is going to help you to make some more educated explanations of what you think about the data. Okay? All right, so now this last part is you looking for that dot plot cool down. And there's some questions for you to try on your own. Pause the video, print it out, do the work, and then you'll be able to see my answer in just a moment. Okay, you should be back. And here we go. So cool down, family size. We've got all of this information. It says how many students responded to the questions. Well, it says 20 students responded, and hopefully you saw that by adding up the dots, and that was 20. Number 2, what percentage of the students have more than one child in the family? So if we're thinking about more than one child, we have to go with all of this information. So when we add that up, I found that that was 15, and 15 out of 20, we can multiply that by 5 each way. That would be 75 out of 100, or 75% of the students have more than one child in their family. Last question, write a sentence that describes the distribution of the data shown on the dot plot. Now, it would be really unusual if you had the exact same sentence as me, but here's what I have. Most students have between 1 and 3 children in their family. You could have something different, but just knowing that the distribution or the spread, you could see that right here, we've got between 1 and 5, where most of the information is here in this range. Okay? So great job today, guys. I know that statistics can get a little tricky when you don't think that there's like an exact right answer. It's just part of learning about it. And it's also part when you think about the graphs and charts that you see in the news or in a textbook or in a thinking of different places, or maybe like when you're watching sports, people sit and analyze these graphs and they make the information work for what they're trying to produce. So it just gives you that information, like it's up for interpretation as long as you can explain your work. And that's why people do talk about statistics so much. It's really important to understand the data so that you don't get tricked by someone who says, hey, this is what you need to know, or this is what I think it is. You have to have that educated guess as to what the data means to you. Okay? All right, well, good luck, guys.